Well, hello everybody and welcome. Hope you're all well and welcome to another session. My name's Des Thatcher. Another session with Let's Code for the older folk. Got a really exciting project for you today. What we're going to be taking a look at is interacting with the ESP32's GPIO pins using MicroPython. But last time we looked at digital. Well, this time we're going to read digital and analog inputs and how to control the outputs and how we generate what's called a PWM signals. PWM stands for pulse width modulation. Right, now the good thing about the ESP32, let me just go to here. If we look at this, you can see that we have pins here. If you can see them in pink, ADC, and they've got numbers. ADC stands for analog digital converters. Okay, so we can use analog devices on those pins. If you look, it's on the left hand side, and if you look, pin 3 to 13, GPIOs 26, 30, 34, 35, 32, all the way down, and one right at the bottom, GPIO 13. They are analog digital converters. Right, so that's what's really good about that. Right, what we're going to do, I've already built a circuit to save time, but I am going to talk you through building a circuit, and what we're going to introduce is one of these. See if you can see that. Okay, it's a potentiometer. All right, and this is an analog device. Zoom in, let's have a look. There we go. It's got 3 pins. All right, the middle pin again is signal pin. Left pin is ground. Right pin is power. Right, so that is a move some stuff. Okay, what I'm going to do, we're going to go through one component at a time. All right, and talk you through it. So first of all, we're going to do the potentiometer. Now, the left leg of the potentiometer, all right, goes to ground. The right leg of the potentiometer goes to 3.3 volts. The middle leg of the potentiometer, actually what I'm going to do, let me bring up the drawing so you can see, all right? And the middle leg of a potentiometer, just need to check what pin it is. I believe it's pin 34. Yep, it's pin 34. Goes to pin 34. So that's the potentiometer. We've then got the 2 LEDs. Both long legs of the LEDs go to the right. Okay, they go to the right. Then the left leg of the potentiometer goes from a 220 ohm resistor across the trench, and then from there to ground. That's on both LEDs. So 220 ohm resistor from the short leg, and then from the other side of the resistor to ground. Then the first, I've got blue, right, goes to pin. I'm just going to check the numbers. Yeah, the blue pin goes pin 4. The next one goes to pin 2. Right, so blue to pin 4, the red LED pin 2, Finally, we've got the button. Remembering that the button has the claws. Okay, remember it's got the claws like so. The claws are attached. The other way against the claws are not attached, and that goes across the trench. The right leg goes to ground. The left leg, the first, we've got a green cable, all right? Green cable, and that goes to pin, check, so this, 15, then goes to pin 15, and then the 220 ohm resistor goes across the trench, from there to ground, okay? So, if you want to stop the video and follow that schematic, all right, and build it exactly the same. All right. So that's the circuit built. Now, what we're going to do is now go on to the coding. All right, the coding for the ESP32. Right, let me just come to here. You're in the right, and this is the first time you're going to see. This is my new Raspberry Pi 5 interface. All right, I haven't really played with it yet. All I know, it's a lot quicker than the Raspberry Pi 4B. There's still a lot of stuff I've got to bring across from the Raspberry Pi 4, a lot of migration to do. All I've really done is just migrated the ESP32 board and Thony. Our Thony IDE. Right? IDE, Integrated Development Environment. Right, now open up your main.py. Right, your main.py folder. Different ways we can do that. File, open. All right, and you can open it on the MicroPython device. Okay, main.py. All right, or you can go file, open recent. Recent files. No, it's not working because I haven't saved it. But yeah, normally you can open recent files. Anyway, so let's go to the code. Right. So we've got our original main.py. Now what we're going to do, we are going to type from machine import pin. All right. So we're importing pin, and it's comma. Just make sure I'm in the right view. Yep. Okay. So it's important. It's comma, space, ADC, capitals, comma, space, PWM, pulse width modulation. All right. So we're importing the pin. We're importing our ADCs. All right. Our analog and digital converters, and we're importing pulse width modulation. And then the next line, from time, import sleep. Good. Right. So that's that. Now we're going to come to LED equals pin. Now this time we're on pin 2. Right. Come across, comma. You get this out of the way. And then, yeah, it's pin out, brackets off. Now, next, our button pin. All right, our button pin. Let's come down. Remember, we put this on 15. Right. So there we go. Come to the end, and it's an input, of course. So it's pin capitals .in in. So far, so good. Hopefully I'm not going too fast. Now we want to configure the ADC for the ESP32, right? So the first command is pot, right, equals ADC, capitals, brackets on, pin, capital P on the pin, right, brackets on, and we put that on 34, right, and then it's 2 brackets off. Right, brackets have changed colour, everything's hunky-dory. Right, the next, pot, dot, width, 2 H's, no, brackets on, and it's width, not width. Okay, so pot, width, brackets on, ADC, capitals, dot, width, all capitals, underscore, 10 bit, so 10 capitals BIT, brackets off. I'll explain this all in a minute when we go through the code. All right, I'll explain it all in a moment. The next line is pot, dot, A, double T-E-N, brackets on, okay, for attention, ADC, capitals, dot, ATTN, capitals, all right, then it's underscore, 11 dB, and the dB is capital. Rightio, and that's brackets off. Then we come down, leave a little space. Okay, there's space. So that's that done. Now, what we need to do is LED underscore pulse width modulation, PWM, all small case, equals. Now we need to tell what LED we're using for PWM. All right, space, capitals PWM, brackets on, pin, capital P on the pin, brackets on, and we put that on pin 4, brackets off, and comma, and we put 5,000, brackets off, enter. Come down, take that space up, and now we want our while true. Okay, now we want our while true. So, enter, while true, enter. Then we put button underscore state. Space equals, equals button dot value. Okay, brackets on, brackets off. Next, LED value, button underscore. Okay, sorry, underscore, and we take out value, take out the value, and we put state. Take out the brackets on, brackets off. All right, so we'll go through that again. Button underscore state equals button dot value, brackets on, brackets off, I forgot. Okay, then LED dot value, brackets on, button underscore state, brackets off, enter. All right, now pot underscore value base equals base pot, and we need to tell it to read, so it's read, all small case, brackets on, brackets off, enter. LED underscore PWM pulse width modulation dot the duty cycle, all right, which we'll explain later, brackets on, pot underscore value and brackets off, enter. And then we need a sleep dot 0.1. Remember, it's all in milliseconds, all in milliseconds. All right, so that's our code. That's our code. Let's just file and let's just save that. Okay, it's saved. Right, and now what we'll do, we'll just go quickly through and explain. All right, now remember we've done this before. First line of code. All right, what we've done from the machine module, okay, we've imported classes. All right, we've imported pin class to interact with the pins, the ADC class to read the analog value, and the PWM class to generate the pulse width modulation signal. Right, so then we've imported sleep from the time module. All right, and then what we've done, after importing all the necessary modules, which we've done, okay, we've now initiated our pin object called LED. All right, and we put that on a GPIO2 output, and then we've put our pin object button on 15, which is an input. All right, and then what we've done, we've made it an input. And then next we've got our pot, 3 pots, okay, and that's what that does. It refers to the GPIOs we want to control, the width. All right, so pin mode, okay. Then we've got our PWM pin on pin 4. All right, and on pin 34. So it creates an ADC object here. All right, pin 34. Right, and then pot 10. All right, line 11 dB. All right, defines the able read voltage. Right, the read voltage in the full range. Right, this means we want to read the voltage from 0 to 3.3 volts, because that's to 3.3 volts. The 11 dB, okay, we want to read 10-bit resolution, the width 10-bit resolution, and it will accept 9 to 12 bits. All right. Then the next line, we're initiating our PWM. All right. So that's it. That's that so far. Okay. Right. Quickly gone through the code. We run it. Okay. Run current script. We did save it, didn't we? File. Yeah, we saved it. And let's run the script. Okay. Right. Good. Looks good. Just try me pot. Yeah. Okay. Let's come over to instruction. Where am I going? Overhead. There we go. Okay. So here we got our little setup. This is really, I find this quite exciting. Okay, so first thing I'm going to do is press the button and the red LED comes on. So that's the digital side of things working, right? The digital side of things working. You can see that. And it's a little bit awkward to get to the pot. But as I turn it up, you'll see the brightness higher and higher. So there we go. We've got the analog side of things working. I'm quite impressed with that. You should be if you've achieved this. All right. So well done, everybody. Well done. Okay, yeah, great stuff. Great stuff. Okay. Great. Well, there you go. There you go. We have combined digital and analog. All right. Components. All right, components. That's what they are. They're components. So hopefully you enjoyed this. If you did, or even if you didn't, please give us a thumbs up. Subscribe. And I'll see you in our next session. Okay, lovely. Thanks very much indeed. Stay safe. Bye-bye.